In this section 1.1, we are going to discover things about points, lines, and planes, which are the foundations of geometry. So to start, we'll have some vocabulary. The words point, line, and plane are actually undefined in geometry, meaning there is no formal definition, but there is a general agreement of what they mean. So again, point, line, and plane, they are undefined terms in geometry, but mathematicians globally have come to an agreement of what they mean. So again, they are undefined, but we just all have a general understanding of what they mean. So in the next slide, we'll discover what points, lines, and planes are, even though they're not really defined in the terms of geometry. So once again, in this slide, we are going to talk about the undefined terms. So we're going to attempt to define these undefined terms. So the first one is a point. So a point has no dimension. It's more like it's just a place in space. It is represented by a dot, as it's seen over here, and you name a point by using the word point and whatever capital letter the point is being named. So this would be point A over here. A line has one dimension, so it's not just a place taken up in space. It actually has one dimension. It is represented with two arrowheads. So if you look at this diagram, we have the arrow over here and the arrow over here indicating that this is a line. And it extends without end. So we know it's going to continue this way forever and this way forever. Through any 2 points, there's exactly one line. So as long as you have 2 points, you can fit one line in between those 2 points. So again, it takes 2 points to make one line. You can use any 2 points on a line to name it. So let's say that there was a third point on here, like point C. We would not call that line ABC. You only use 2 points to name a line. So as you see here, they have named this line also with this cursive letter L. It is very common to name a line just by a lowercase and often cursive letter. So here we see line L is a name, and again we use the word line. We could also name it as line AB and use the word line, or we can name it as line AB with the symbol of a line on top. And notice that this symbol has two arrowheads indicating that it is a line and not like a ray or a segment. Another way to name it would be line BA. You do not have to go in alphabetical order. So we did AB before, you could flip it around and say BA. And again, you can use the word line or you can use this symbol for a line. And again, you would want to make sure that you have the double arrows. Geometry and math in general has to be very specific, so you have to be very careful about what you are writing down. If you're indicating a line, it has to have the arrows. So once again, 2 points on a line, that's what you use to name it. For a plane, our third undefined term, it has 2 dimensions, so it's like a flat surface. It is represented by a shape that looks like a floor or a wall, but it extends without end. So we see here this plane right here, but it would go off in this direction forever, off in this direction forever, this direction forever, and this direction forever. So it's just like a flat surface. I kind of think of it like a knife cutting through something. Through any 3 points, not on the same line, there's exactly one plane. So you have to have 3 points, but those 3 points cannot be on the same line. And that is what makes one plane. You can use those 3 points that are not all on the same line to name the plane. So again, just like it takes 3 points, not all on the same line to make a plane, we use those 3 points to name the plane. So you use 2 points to name a line and 3 points to name a plane. So you see here we have points A, B, and C on this plane, and I could not fit just one line through all 3 of those points. So these would not all be on the same line. So they've called this plane ABC. And again, you don't have to go in alphabetical order. I could have done CBA and it would have been fine. They can also name a plane by a capital letter. So you can see here they have named it plane M, and M is not a point on the plane. They just call it plane M. And if you see that a plane is named by just a capital letter, you would then assume that that point is not on the plane. So 1 point for a point, 2 points for a line, 3 points not on the same line for a plane. Collinear points are points that are on the same line. So if we dissect this word, you see the word linear in there, which means line, and co as a prefix usually means together. So together on the same line. So collinear points are points that are on the same line. Coplanar points are points that lie on the same plane. So again, if you dissect this word coplanar, you see the word planar in there, which means plane. And again, co means together, so together on the same plane. So coplanar points are points that are on the same plane. So back to this word collinear. If we put non-collinear in front of collinear, so non-collinear would mean that points that are not all on the same line. So back to the plane, if we are supposed to find 3 points that are not all on the same line, we can call those 3 non-collinear points. So again, you'll often hear me and see in the textbook, when you're naming a plane or trying to identify a plane, you're going to be looking for 3 non-collinear points. So again, collinear means together on the same line. So non would mean not together on the same line. So we could actually rephrase this and say through any 3 non-collinear points, there's exactly 1 plane. And that is what you will hear me and also other resources say. Instead of just saying not on the same line, we'll use the word non-collinear. So let's take a look at example number 1. We are going to use this diagram over here on the right in order to answer the 4 questions on the left. So part A says give 2 other names, and notice how I'm going to read this. I'm going to read it as line, since this is a line symbol, BD. So again, it would be give 2 other names for line BD. So let's look for line BD over on the diagram. So I find B right here and D right there. So we're talking about this line right here. We need to give 2 other names. So one way we could name it is line, again, line DB. So I just flipped the letters around because remember it does not have to go in alphabetical order. I could have also used the word line and said just line DB in words rather than use the symbol. Notice also that they are naming line DB over here with this lowercase m. So I could write it as line M. So notice I used the word line while using that lowercase m. Typically, when you use a lowercase letter to name a line, you're going to use the word line instead of the line symbol. So again, you can always use the word line or the symbol for the line when you are using 2 letters or 2 points to name the line. But again, you're going to use the word line typically when you're using a lowercase letter to name the line. And remember, M is not a point on the line. They're just naming that line M. For part B, it says give another name for plane T. So we're looking at this gray area right here. If they're naming it plane T just with 1 letter, that would indicate to me that T is not a point on the plane. Rather, they're just naming the plane T. So what I'm going to look for is 3 non-collinear points. Remember, 3 points, not all on the same line. That is what makes a plane. So if I look here, I see this line L, and it has points A, B, and C on it. So A, B, and C are collinear, so I do not want to use points A, B, and C to name plane T. What I want to do is take 3 points that are not all on that same line. I also am not going to use point D over here because it's not on the plane at all. So what I'm going to do is pick 2 points from this line L and then E over here since it is not on the same line as the other 3 points. So another name for plane T would be plane ABE. Again, I'm just choosing 2 of the points on line L and this 3rd point E, which is not on the same line. I could have just as easily done BCE or BAE, but E would have to be in the answer since it is the only point on that plane that is not on that line L. Also, just a quick note, L is not a point on that line. They're just naming that line with that lowercase cursive L. For part C, it says name 3 points that are collinear. So kind of back to what we were talking about in part B, the only 3 points that are all on the same line in this diagram are A, B, and C. B and D are on the same line, but we don't have a 3rd one, and they want us to name 3 points. So our answer for part C would be A, B, and C. Notice that I did not use the word point. typically you can just refer to a point just by its letter. You don't always have to use the word point A, point B, point C. People will still know what you mean. For part D, it says name 4 points that are coplanar. Well, the only plane that we have in here is plane T. So we need to find 4 points that are all on there. So again, we have A, B, and C. Those are collinear, but we just need a fourth one that would be non-collinear with that to make sure that they are all on the same plane to make them coplanar. So we would answer it as A, B, C, and E. Once again, we would just stay away from using point D because it is not on the plane over here. This line is going through the plane and point D is over here kind of behind it. So again, we want to use all the points other than D. Now we're going to talk about terms that can be described using words such as point, line, and plane, and these are called defined terms as opposed to the undefined terms point, line, and plane. So now we're going to use those undefined terms to now build actual definitions of things that can be defined. So again, point, line, and plane are kind of our foundation, and those are undefined to build off of to now define all other terms that we're going to be using in geometry. So let's look at those defined terms. So the defined terms that we are going to talk about are segments and rays. And once again, we're going to start with terms as point, line, and plane to build off of those for now our defined terms. So line AB, and again you would write it with the symbol line AB, and points A and B. So again, we're using the undefined terms line and points to use to define the terms below. So again, our first one is a segment. So the line segment AB or segment AB, so you can use the word or the symbol. So notice here, this is different than a line symbol because we are not using the 2 arrows. So line AB would be different than segment AB because a line goes on forever and a segment has 2 distinct endpoints as it says here. So again, segment AB consists of endpoints A and B and all points on line AB that are between A and B. So a line goes on forever. A segment is finite, meaning it has a beginning and an end. So notice here we have endpoint A, endpoint B. So the segment would be all points in between those 2 endpoints. Note that segment AB can also be named segment BA. So again, you can always use the word, but we also now have the symbol. You always name a segment using its endpoints. So we do not have any other points to name it. So you need 2 points to name a segment, and it has to be the endpoints that make up that segment. For a ray, our second defined term, the ray AB, and you would name it as ray AB, and notice that this one has 1 arrow, consists of the endpoint A and all points on line AB that lie on the same side of A as B. So what this means is, if A is our endpoint, to name this ray in this direction, we need to name 1 other point in the direction that it's going, so this would be B. You always name a ray starting with its endpoint. So if you see here, we have a different endpoint, B. So we would name that as ray BA. So since it had a different endpoint, we start with endpoint B, and then since it was going to the left, we named 1 other point in the direction that it was going, so that would be A. So note that ray AB and ray BA are different rays. Another thing that I catch kids doing from time to time is because this ray is going left, they think they can write it as this. They think they can flip the arrow around since it's not going to the right, it's going to the left. They think they can flip the arrow around. They still put the B over here because it would correspond with the endpoint right here, but so they would think that this means the same thing, but it's not. You always use a right arrow such as this to name a ray. All ray symbols point to the right. So you just start with the endpoint and name 1 other point in the direction that the ray is going, and you name it as if it's going to the right, even if it's going to the left or up or down or whatever. If point C lies on line AB, again, notice how I'm reading that, line AB, since I had 2 arrows. So again, if point C lies on line AB, between A and B, so as you see here, C is between A and B, Then ray CA and ray CB, so here's ray CA and ray CB, are opposite rays. So opposite rays share the same endpoint. So notice here that we had a C that we started with and a C that we started with. So opposite rays always have to start with the same letter. And then basically they're just making up one line. So you have this line AB, but the C's between it. So we have this ray going to the left and this ray going to the right, making up that full line. So two rays that make a line and share the same endpoint are called opposite rays. So you would never have opposite rays that don't start with the same letter. Segments and rays are collinear if they lie on the same line. So just like before when we had collinear points, segments and rays can be collinear if they also lie on the same line. Therefore, opposite rays are collinear. Again, as we said before, opposite rays basically make a line together where they share that same endpoint going to the left, going to the right. They're making that same line, so therefore they would also just have to be collinear if they're making a line themselves. Lines, segments, and rays are coplanar if they lie in the same plane. So again, like before when we had coplanar points, we can also have lines, segments, and rays if they are all lying on the same plane, and so we would call them coplanar. So here's example number 2. Again, we're going to be using this diagram at the right in order to answer the 3 questions on the left. So part A says give another name for, notice how I read this, segment PR. I know this is a segment because I don't have any arrows on the symbol. So here's segment PR. You only name segments with their endpoint, so the only other way I could name this is segment RP. I could also use the word segment, but typically we just stick to the symbols. Part B says name all rays with endpoint Q. So looking at the diagram, we see Q, so there would be 4 rays, ray QP, QT, QR, and QS. So remember, you have to name a ray starting with its endpoint. So if they all have to have an endpoint of Q, like it says in the problem, notice that all 4 of my answers have a starting letter of Q. Even though QS went to the left, I still named it as if it was going to the right. And then part C says, which of these rays are opposite rays? So remember, opposite rays share the same endpoint, and they basically form a straight line. So rays QS and QT would be opposite, and rays QP and QR would be opposite because, again, they are forming those straight lines. We'll end this section by talking about intersections. So 2 or more geometric figures intersect if they have 1 or more points in common. The intersection of the figures is the set of points the figures have in common. So we'll look at what happens when 2 lines intersect and 2 planes intersect in our diagrams here. So the intersection of the 2 different lines, line M and N, notice that they intersect at exactly 1 point. So 2 lines intersect at 1 point. For the 2 planes over here, the pink reddish plane and the blue plane going up and down, since planes go on forever, when they slice through each other, that area that they are intersecting would actually be a line because this plane's going to keep going that way and to infinity. So the intersection of 2 different planes is a line. So let's write this down. 2 lines intersect in a point, and exactly 1 point. 2 lines would never intersect in more than 1 point. A line and a plane intersect in a point. So if you think about drawing a line through like this pink plane over here, it would enter here and come out the bottom. So it's going to intersect in just 1 point. So 2 lines intersect in a point, and a line and a plane intersect in a point. 2 planes intersect in a line. And this was probably the hardest one for kids to imagine in their heads, that the planes go on forever, so when they slice through each other, they're going to be intersecting in that kind of that crease in between, and that crease would go on forever since planes go on forever. So 2 lines intersect in a point, a line and a plane intersect in a point, and 2 planes intersect in a line. I'd be sure to write that down in my notes. That's it for this section. Make sure you jot down anything you did understand that we can cover in class before we move on, and we'll see you then.